Hi guys, welcome to another problem of vertical throw. Okay, so this is the second problem. It says a game is about to start and the referee flips a coin. So that means that is going to throw this coin vertically upwards. And 3 seconds later, she catches. She catches the coin. So what was the initial velocity of the coin? That's the first question. And the second question, what is the maximum height the coin reach? So let's make the problem. I like to make the problems over here. Okay. So I'm gonna make the drawing. This is the referee. Okay. And this is the coin, and it's going to oops, let's change the color. Oops. Okay, so this is the coin, and she's going to throw it upwards, something like this. And of course, it's going to return to the same place. And I means it's going to return to the hand. Okay, but I need to do this kind of drawing in order to show what is going to happen. Okay, so the total time, okay, the total time from the beginning until the coin returns to the hand, it's 3 seconds. Okay, so that's 3 seconds. That's the only data that they give me. But don't worry, I don't need much in order to do this problem. Okay, so let's just remember that if we divide this into segments. Okay, so this is the segment number 1 when goes up, and this is the segment number 2 when goes down. So remember that this is the initial position of the segment 1, that most of the times is 0. This is the initial velocity of the segment 1, which I don't know. Also, this is the final position of the segment 2. Okay, in this case is 0 because that's where the motion starts. And this is the final velocity of the segment 2. That in this case, I don't know, but it's going to be the negative velocity of the initial velocity of the segment number 1. Just remember that, please. This is the highest point, okay? I need to erase this because I'm gonna write them a little bit over here. This is the segment number 1 and this is the segment number 2. So this is the final position of the segment 1. That will be the maximum height, okay? And also this is the final velocity of the segment 1. That in this case it will be 0 meters per second, because remember that the velocity at the highest point is going to be 0 meters per second. Always. And then, okay, this is the initial position of the segment number 2. That is the maximum height. Okay, and this is the initial velocity of the segment number 2. That is 0 meters per second, because remember that in the segment number 2 we have free fall, and the initial velocity in free fall is always 0 meters per second. Okay, also well, for both segments I'm gonna have the gravity, the value of the gravity. That is, I'm just gonna write it in the segment number 1. Gravity acceleration, that is the value of the gravity, that is minus 9.8 meters per second square. Okay, and I'm gonna have the time 1 and the time 2. Okay, so this is the time 2, this is the time 1. Remember that they are gonna be the same, so that means that time 1 is 1.5 seconds, because I need to divide the total time by 2. Okay, so total time 1 is 1.5 and time 2 is 1.5 seconds. So that will be the drawing with all the data. Okay, so I don't have to write again all the data. Okay, the only thing that I'm going to do next, I'm going to do it over here. I'm going to write the equations that I have. That is acceleration equals final velocity minus initial velocity over time. And the other equation, final position equals initial position plus initial velocity that multiplies the time plus the acceleration, the acceleration that multiplies the time raised to the square over 2. Okay, so let's see the questions because I don't remember. It says what was the initial velocity of the coin. So they are asking me about this initial velocity of the segment 1 or the final velocity of the segment 2. Okay, but remember that it's going to be the negative sign. And also remember that you can choose any segment that you want. You can choose the segment number 1 to do this problem or the segment number 2. Okay, it doesn't matter. If you made the correct procedures, you're gonna get the same answer. So in this case, I will choose, I don't know, I'm gonna choose the segment number 1. And okay, in segment number 1, let's see what I have and what I don't have. So acceleration, yes. Final velocity in segment 1 is 0. Initial velocity, no. The time of the segment 1, yes, I have it. So I can use this equation in order to find the initial velocity. Okay, so I'm gonna cancel the final velocity of the segment 1 because it's 0. Remember that the velocity at the maximum point is 0. Okay, so acceleration equals minus initial velocity of the segment 1 over the time of the segment 1. Okay, so I'm going to isolate the initial velocity. That in this case it will be initial velocity of the segment 1 equals minus the acceleration that multiplies the time 1. So this will be negative 9.8 meters per second square times 1.5 seconds. Okay, so this square is going to be eliminated with the seconds, so I'm just going to have meters per second. So let's get the calculator. Negative parentheses negative 9.8 times 1.5 seconds equals, okay, that is the initial velocity. And if you see, it's not an infinite value, so it's not necessary to save this value in a memory of the calculator. So initial velocity of the segment 1 equals 14.7 meters per second, and that is the velocity that was used to throw or to flip the coin vertically upwards. Okay, so that's the letter A. I'm gonna write that. This is letter A. Now, what is the maximum height the coin reach? Okay, so I need to find. I need to find final position of the segment 1 or initial position of the segment 2. Now I want to choose the segment 2 because I don't want the segment 2 to feel I don't know, excluded, so I'm gonna use it. So in segment number 2, final position in segment number 2 is 0. Okay, so I got this one, I got this one. Initial velocity of the segment number 2 is 0, so I have it. I got this one, I got this one, and I got this one. Oh, sorry. I don't have this one. So that's the one that I need to find. Okay, so I can use this equation to find the initial position of the segment 2. But before I do it, let's cancel everything that is 0. So final position is 0 and also the initial velocity. Okay, just remember that. And so this equation will be initial position, oops, sorry, I'm gonna change the color. Initial position of the segment number 2 equals minus, yes, because I already got the equations, okay? These equations are from free fall, so I'm just going to isolate the equations. Initial position equals minus the acceleration that multiplies the time of the segment 2 raised to the square over 2. Okay, so let's do it in the calculator. This is, well, first this is negative minus 9.8 meters per second square. That multiplies 1.5 seconds raised to the square over 2. So initial position of the segment 2, that is the maximum height, is fraction negative oops, negative 9.8 times 1.5 raised to the square over 2. Okay, and that is the maximum height, 11.025 meters. Well, to be honest, that coin went too far. The referee was strong, and yes, pretty strong. So this is the problem number 2 of vertical throne. If this is your first video that you watch, please, this is a video that forms is included in a playlist with all the topics of the course of Physics 2. So, well, I hope I see you in the next video. Okay, see you guys. Bye bye.